M87. A supermassive black hole of dark matter. Now we know what's inside. A black hole is an extremely dense object from which no light can escape. They are often formed when a star collapses in on itself. The massive gravitational force of the black hole pulls all matter and energy towards it, creating a point of infinite density. Welcome to the Space Side YouTube channel. Before starting this video, like this video and subscribe to our YouTube channel for future updates. Black holes can be either supermassive or stellar. Supermassive black holes are the largest type of black hole and are usually found at the center of galaxies. They can have a mass that is millions or billions times that of the Sun. Stellar black holes are smaller, with a mass that is a few times that of the Sun. They are typically formed when a star explodes in a supernova. M87 is a supermassive black hole that is located in the Virgo galaxy cluster. It has a mass of 6.5 billion times that of the Sun. The black hole is surrounded by an accretion disk of gas and dust. As matter falls into the black hole, it releases a tremendous amount of energy. This energy is what powers the accretion disk and makes it glow brightly. Previous research has found that the black hole in M87 is growing at a rapid rate. It is thought that the black hole is feeding on dark matter particles. This would explain why the black hole is so massive. The research provides insights into the mass distribution of M87 and the role that dark matter plays in the growth of black holes. This research will help us to better understand the universe and the role. It's generally agreed that, in the innermost kiloparsec, the energy and angular momentum of the DM particles must have been cut off by some form of self-interaction or interaction with regular matter. This would allow the dark particles to fall into the central black hole. This means that the mass of the central black hole in M87 is partially made up of accreted dark matter. Therefore, M87 has a giant black hole of collisional dark matter at its center. M87 is an extremely distant massive object, located 55 million light-years away in the Virgo galaxy cluster. It has a staggering mass of 6.5 billion times that of our Sun. The bright circle of gas and dust that orbits it is known as an accretion disk. Even though it's very large, it takes many days to orbit M87 completely. The accurate mass distribution of M87, the giant galaxy with imaged shadow of its supermassive black hole, as a portal to new physics. All of this information provides us with discoveries of cosmological relevance. Thanks to high-quality photometric and spectroscopic measurements, we now have a better understanding of M87 and can use it as portal to new physics. Additionally, this new research provides insight into the fine-tuning between the mass of the black hole and the surrounding stellar spheroid. It's clear that in M87, both dark matter particles and standard matter have contributed to the growth of the central black hole. It's generally agreed that, in the innermost kiloparsec, the energy and angular momentum of the DM particles must have been cut off by some form of self-interaction or interaction with regular matter. This would allow the dark particles to fall into the central black hole. This means that the mass of the central black hole in M87 is partially made up of accreted dark matter. Therefore, M87 has a giant black hole of collisional dark matter at its center. Comment and subscribe to the channel to stay updated. Thank you for watching.